Now, like terms are terms in an algebraic expression whose variable factors, now this includes the variable and the exponent on the variable, are exactly the same. So in example 1, all we want to do is identify the like terms in these expressions. In this first one, we have 3a minus 6a plus 10a minus a. If you notice in all of these, the variables are the same. Each of these terms has the variable a. So all of these terms, all 4 of these, are like terms because the variable factor is the same. So the like terms here are going to be all 4 of them, the 3a, the negative 6a, the 10a, and the negative a. Now in this next one we have 5x minus 10y plus 6z minus 3x. For like terms, remember we're only looking at the variables. Here, this first term and the last term both have x as factors, so those are like terms. So the 5x and the negative 3x are like terms. The other two, the negative 10y and 6z, are not like terms. So I'm just going to list them by themselves down here. This last expression, we have 7n plus 3n squared minus 2n cubed plus 8n squared plus n minus n cubed. Remember, like terms are the variables with the exponents. So looking at these, we have 7n and n. Those are like terms. So 7n and n. Now the next one, 3n squared, we're looking through this expression to find another n squared term. And there's one right here. So these are also like terms, the 3n squared and the 8n squared. Now these n cubed terms are like terms as well. So in this expression we actually have 3 sets of like terms. This last one being the negative 2n cubed and the negative n cubed. Now once we have identified the like terms, we can simplify the expression by combining them. Now in order to combine like terms, you want to focus on first identifying them and then adding or subtracting the coefficients. So in this first example, 3a minus 6a plus 10a minus a, all of these were like terms. So to combine them, you add and subtract the coefficients. The coefficient of this first term is 3. Then we have a negative 6. Then we have a 10. And this last one, the coefficient would be a negative 1. So to combine them, we would take 3 minus 6 plus 10 minus 1 and attach all that to the variable factor, which is a. Working this out, 3 minus 6 plus 10 minus 1 gives us 6a. So this expression right here, because all of the terms are like terms, simplifies down to just 6a. Now this next one, we had the 5x and the negative 3x were like terms, so those can be combined. So we'll have the coefficient here was 5, the coefficient here was negative 3, those were x terms. And then copying down the rest of these, there's minus 10y plus 6z. Simplifying this, we have 5 minus 3 is 2x minus 10y plus 6z. Now with what we have here, there are no like terms remaining in the expression. In this last one, the 7n plus 3n squared minus 2n cubed plus 8n squared plus n minus n cubed, We had several sets of like terms, so each of those sets needs to be combined. Starting with the n terms, we had 7n plus 1n. Again, even though you don't see it there, you can always imagine a 1. Plus, do the same thing with the n squared terms. Here we have 3n squared and 8n squared. So 3 plus 8 n squared plus, and do the same thing with the n cubed terms. Negative 2 is one of the coefficients. The other coefficient, imagine there's a 1 there, and the negative sign makes it negative 1 n cubed. And then simplify. 7 plus 1 is 8n plus 3 plus 8 is 11. That's our n squared. Plus negative 2 minus 1 gives us a negative 3. And I'm just going to include some parentheses to separate that negative value. That is n cubed. Now, the last part of this, I want to resolve these two signs. We have plus a negative 3. That would be the same as minus 3 n cubed. So copying down the first part of the problem, we have 8n plus 11n squared minus 3n cubed. Now, one last piece of this third example here. Whenever you have an expression with the same variable, different exponents, you want to write it in what we call descending order. And what that means is, if you look at the exponents, you want to start with the largest exponent, the term with the largest exponent, and step your way down. So just rewriting this, all I'm going to do is reorder this right here. The term with the highest exponent is this one right here. So I'm going to start with negative 3n cubed. The next highest power is 2, so I'm going to write that term next, plus 11n squared, and then 8n last.